Hello, and welcome back to another RostyMaths video, and welcome to my Year 9 series on number. Now, even though I say Year 9, did you see the thumbnail? It says GCSE 9 to 1, so this is a GCSE topic. So if you're studying for GCSE, please make sure that you do keep track of these videos that I am doing. Anyway, in this video, we are going to rationalize surds, and that, well, you have to watch the video to find out what it's all about. So keep an eye out for that. If you are new here though, hit that subscription button and click the notification icon so you do not miss another upload. The videos do come out pretty furious and fast, and I wouldn't like you to miss anything out. Anyway, without further ado, let's go and rationalize some surds. Okay, welcome back to another video on surds. This is going to be the last video on surds. I'm going to make the assumption that you've watched the other 3 or 4 videos I've done on surds, because everything that I've done so far comes into culmination on this last topic of rationalization. Now, what does rationalization mean, or what does it mean to rationalize a surd? Us mathematicians, we don't like square roots in our denominators. So every time you see rationalization, you will almost always see it with a fraction. So you will have a fraction there, and you're going to have square roots in the bottom. And if you've got square roots at the bottom, you need to get rid of it. And how you get rid of it is you multiply it by an invisible fraction. Now, the invisible fraction will always need to have something from the denominator that you need to get rid of. In this case, I want to get rid of root 6. So my invisible fraction will be root 6 divided by root 6. Why is it an invisible fraction, you ask? Well, what's root 6 divided by root 6? It is 1, because you've got the same thing on the top, same thing on the bottom. So when you divide 2 of the same things, you get 1. And if I multiply 1 by this, well, then I get the same thing back. So that's why it's invisible. Or is it? Because let's see what will happen. Now we've got 2 fractions, fraction here and fraction there. And we need to multiply these fractions together. And to do that, we will multiply the numerators, multiply the denominators, and see what we get. Let's go. So this then equals to, when I multiply the numerator, 6 times root 6 becomes, you guessed it, 6 root 6. And root 6 times root 6, well, that is just 6. Now, if you don't know how I got that answer, check on the pop-up banner and go and look at my last video on expanding brackets. But when you multiply 2 square roots and it's got the same thing inside, the square root will just disappear, leaving you with that thing there. Oh, well, look what's going on. 6 divided by 6. Not this one in here. This one is locked in that square root. You can't touch it. But this one, in these ones out there, you can cancel them out. So therefore, the final answer in this case is just the square root of 6. And just like that, that is finished. Okay, and that's rationalization, guys. We can pretty much end the video here. But why should we? Because every single question I've got here are different. You want to stick around to see this one. This one's going to be fun. Anyway, let's go. So on the second one, again, there is a square root in the denominator. It needs to go. We need to rationalize. And because this is what needs to go, this is what I'm going to multiply by with my invisible fraction. So let's get my invisible fraction going. It's going to be root 3 over root 3, like that. And then we go work it out. We do our denominators just like we did on the top. So no need to scaffold it like this. You know what's going on. 2 times root 3. That gives me 2 root 3. And then down at the bottom, that 7 will still stay there. But root 3 times root 3 is 3. So that's going to be 7 times 3. Because this 7, he's got no friends to multiply with. Well, there's a 1 here, but, 7 is there. And then root 3 times root 3 is 3. So 7 times 3. Let's finish off this one, because this one's pretty quick and easy. 2 root 3 divided by 21. This is now finished. Okay, nothing else we can do there. The denominator has no square roots in it. It's been rationalized. Now, things are starting to get interesting here. And no, your invisible fraction is not just going to be root 2. You need to think about the fact that you've got something added to that root 2. So what you need is a conjugate. Yes, that's right, I said it, a conjugate. And the conjugate is going to be 2 minus root 2. Can you see what's different? This one had a plus, this one has a minus. And what I've created here is a pair of difference of two squares that matches with that. And that's going to create something rather incredible. And I only need to show it to you once. And once I've shown it to you, you'll be good to go. So here we go. Again, just do the top. 1 times all of that. That's not going to change. So 2 minus root 2, that's done. Divided by. Now this bit on the bottom here, this is going to take some doing. So let's go and do some work on the side with this. So now I'm going to take my 2 add root 2 and my 2 minus root 2. Now I've covered this in my last video, as I've mentioned before. It's worth having a look at it, but here we go. First times first. I'm using FOIL, by the way. That's going to be 4. Then the outer, that becomes take away 2 root 2. Then the inner, that becomes add 2 root 2. And then the last, and that's going to be minus 2. Okay, because root 2 times root 2, that's just going to be 2. Okay, this will always happen when you do a conjugate, and that is the middle will cancel out because that's negative 2 root 2, that's positive 2 root 2. If you see a time when they don't cancel out, please do let me know in the comments below. But this becomes 4 take away 2, which is just 2. So again, these cancel out, and then 4 take away that 2 is 2. So finally then, it means that this final answer is that is over 2. And just like that, that question is finished. Literally, that's it. Did you see that answer coming up? Leave us some comments in the comments below. All right, let's finish off this question then. Again, feel free to pause the video, see if you can have a go on your own. It would be really cool if you did, and then check your answers. But let's go do this last one. So again, the conjugate is going to be 1 add root 2 this time. So 1 add root 2. And don't forget, the conjugate is always going to be slightly opposite to this. That's a minus, that's a plus. When we did it over here, it was a plus and we changed it to a minus. Okay, let's do the top and the bottom. So for this one, I'm going to work with a couple of different colors. Let's do the top. The top is 1 add root 2 there. And I have got 1 add root 2 again. So I'm just going to multiply them out. I'm going to use FOIL. First times first, that's 1. So now we do the outer, and for the outer, I'll do 1 times root 2. So that's going to be add root 2. Then we do the inner, 1 times root 2. So that's add root 2 again. And then we do the last, root 2 times root 2. That's just going to be 2. Now we can add the middle up. So this becomes 2 lots of root 2's because I've got 1 root 2 plus another root 2 means 2 root 2's. And that 1 plus that that 1 plus that 2 is going to be 3. So at the top, I have actually got 2 root 2 add 3. Now, in the denominator, same as we got up here, the middle is going to cancel out. So you can almost just multiply the first. 1 times 1, that's 1, which is just going to be 1 there. And then root 2 times root 2, that's going to be take away 2. So the final answer here is going to be 2 root 2 add 3 divided by negative 1. We don't like negatives in our denominator, guys, so we can actually just put a negative on the outside here and say that that's 2 root 2 add 3 if you want. But however you look at this question is finished. Now, I'm going to go back to something real quick, and I'm going to assume that when I did this part over here, I completely lost you. And if I did, then I'm going to go back and do this now and show you how I know that this answer is correct, okay? So let's jump onto a blue color. So I've got 1 take away root 2 and I've got 1 add root 2. We expand using FOIL again. First, that's 1. Outer, that's 1 times root 2 is going to be added to root 2. And then inner, 1 times minus root 2 is going to be minus root 2. And then last, root 2 times root 2 is just going to be negative 2. The middle is going to cancel out because it's root 2 take away root 2. And then 1 take away that 2 is going to give me minus 1. So next time, to save time, if you can spot it, so long as I have 2 conjugates multiplying, just multiply the first. 1 times 1 is 1. Multiply the last. Root 2 times root 2 is just going to be that 2 there. Don't forget the minus. I keep not mentioning it, but it's there. And so 1 take away 2, that's going to be negative 1. And that will save you a lot of time of doing this stuff. You don't have to do it if you recognize it. Anyway, just gone 10 minutes in this video. I hope that you enjoyed it. If you did, please give it a like and subscribe to see more content like this. Don't forget to hit that notification bell. I will see you on the next one. This is the last video on surds. You're going to see surds again in other respects, but when you see it again in other respects, it's going to be quite challenging, but at least you got the basis done. All right, see you on the next one.